Okay, this is lesson 11.3, B as in boy, intermediate algebra, and we are continuing to work with logarithms. We're on example number 3, and it's asking us to solve this logarithm. Log with a base of 8 of 4 equals x. Alright, so what we're trying to find out is what exponent can we put on 8 that's going to give us 4? Okay? So that's what we're trying to do. Trying to find out what exponent we can put on 8 that gives us 4. So see how I changed my logarithm into an exponential form just so I could kind of get an idea of what I'm looking for? Alright, so what we're trying to do is solve for x. When we're given a problem like this, and we have all numbers except for the exponent being a letter, we can't do anything until we change the bases to the same thing. This base has an 8, this one has a 4. We can't combine those. We can't do anything unless they're both the same number. So what I'm going to do is I'm going to change that 8 to a 2 cubed. And now it's an 8, right? 2 cubed is 8. And I'll put that x up there. So that's this x. And what is 4? 2 squared. Alright, so because the bases are the same, that means the exponents have to be the same, right? If I have 3 to the second power and I have 3, what number has to go up here? Well, if this is a 3 and that's a 3 and that's a 2, this has to be a 2, because if this is 3 times 3 is 9, this has to be 3 times 3 is 9, so that's going to have to be a 2. So what I'm saying is, if these two bases are the same, that means the exponents are the same. If these two bases are the same, the exponents are the same. So really, at this point, I can get rid of my bases. I don't really care what they are, and I can say that whatever that exponent is, it's going to equal 2. So what is this x then? The x is going to be, divide both sides by 3, 2/3. So my x is 2/3. And if I were to write that in exponential form, that would be written as 4 equals 8 to the 2/3 power. Now, 2/3 power, you're like, what the heck does that mean? Well, the 3 means we take that root of 8, the cubed root of 8. So what's the cubed root of 8? What times what is 8? 2. And then that means we square it. And that would be 4. So, yeah, that's a true statement. Alright, so I know this stuff is tricky. I know you're going to have a hard time, some of you, trying to wade through all of this. And I don't know if some of you have had anything to do with logarithms before. But once you get them down, they're not really too incredibly terrible. Example 4 wants you to graph the logarithm. We're not going to graph any logarithms, but I do want, before I start with example 5, I do want to look in the book and do some switching from exponential to logarithmic and back and forth. So let's take like number 4 in the exercises. At 16 equals 4 squared, and they want you to write it in logarithmic form. So we take log, okay, 16 doesn't change, 4 goes down there, and the exponent is right there. And that's how you switch it, okay? You know there's 3 parts, and here there's 3 parts. And you just move the numbers where they need to go. So I would put something like this in your notes just to remind you of where those numbers move around to. Okay, so let's look at giving them to you in logarithmic form first. So we've got log 10 of 100 equals 2. This is number 13. They want you to change that to exponential form. So 10 squared equals 100. Okay, again, 3 parts, changing it to these 3 parts. So you just move the numbers around so that they're in the right place. That's all you have to do with those. It doesn't matter if they're fractions or decimals or negatives or whatever they are. You know, they're gonna work the same way. So for example, log 5 1 over 25 equals negative 2. Okay? So again, 1 over 25 equals 5 to the negative 2 power. I just switched it to exponential form. Okay? Alright, so let's keep going here on doing some of these, and let's go back to example number 5, and this is on page 679, and we're looking at two special identities. Alright, these identities are just things that you just need to remember. Put them in your notes so that you can write them down. And I have to take my glasses off because I cannot read the writing of this first identity. B. Let's move that B down. Okay. And our exponent is a logarithm. And then we have a base, and then we have an x. And if you get something like that, that equals x. Alright, so what that means is if you're given an equation that is in this form, it's not going to have a b, it's not going to have an x, it might have numbers and stuff. But if you have a b here, you have a logarithm as an exponent with a base of b to x. That means this all goes away, and it just equals x. Okay, so that's the first identity. Second identity is log b of x, and that also equals x. Because what happens here is these b's cancel each other out and the logarithm, and so it's just equal to x. Okay, so those two identities are really important for what we're doing here, and so let's just kind of practice those a little bit, and we'll go look at example 5. So they give us log 2 of 8, and they want us to simplify those. Alright, so this takes us back to some of the other stuff we were doing earlier, and what we're going to do is we are going to basically what this means is there's an unknown over on this side. Okay, so that's kind of what we're looking for, is what that x is. So let's go ahead and instead of 8, we're going to write it as 2 cubed. Okay, now notice what happened here. When I write 8 as 2 cubed, I have two 2's together, and when I have two 2's like that, they go away and the logarithm goes away, and I'm left with a 3, and that's my answer. And that is from the second special identity, the log b of x. Okay, so when I took that 8, when I took this and wrote it as log 2 cubed, it's in this format, and when it's in that format, it equals x, or it equals that exponent up there. So I was able to write it in that format, and then I don't even really have to do any work. So let's leave that particular identity up there. In fact, let's put the other one up there as well. What was it? B, and then log b of x, and that equals x. Okay, so we'll leave those two up there. Let's look at example 6. We have log 10 of 10,000. Okay, so what we're going to do is notice we are going to try to get these two numbers to be the same. kind of like the b and the b here. We want to be the same. So let's make these two the same. Alright, so what we have to do then is write log base 10, and we're going to write this as 10 to the 4th power. Now they're the same. They go away with the log, and we get 4 for an answer. Okay? So we're trying to kind of look ahead and make some changes so that it makes it easier to go ahead and solve these. So let's look at number 7. Number 7 gives me log base b of b, and they're also saying that b has to be greater than 0, but that's neither here or there. Okay, so let's see what we've got here. What is the exponent on b? 1, right? Since there isn't 1, there is an exponent of 1. Okay, so we look back up here, and when our b's are the same, the exponent is the answer. The b's are the same, the exponent is the answer. Okay? Alright, let's look at example 8. We have log with a base of b, and we have 1. Alright, so let's see. Now this is where it gets a little tricky. Not tricky necessarily, but to where you see this kind of stuff. Alright, so again, we want to get this to be the same as this. So we want that to be a b. Well, the only way to turn a 1 into a b is to make it a b to the 0 power, because what do you know about the 0 power? Anything, any number or any letter to the 0 power is equal to 1. Now they're both b's, so your answer ends up very easily being 0 there. Okay? Alright, let's look at example 9. Doggone it. Okay, this just doesn't want to erase very well. Alright, so we have log 4, parentheses, log 5 of 5. Alright, so what are we going to do with that? Well, we know that that is the same as log base 5 of 5 to the 1st power. So we know that this is the exponent. It's 1. So log 4 times 1. Okay. So log 4 of 1. What are we going to do with that? Alright, well, if we write it in exponential form, we get 4 to the x power equals 1. Okay? So, because, remember, we've got an equal sign, that's what we're looking for is on the other side. So log base 4 of 1 equals x. So if we were to change this to exponential form, it would look like that. So 4 to what power is going to give me 1? Well, 4 to the 0 power gives me 1. So my x is equal to 0. Alright, so I do not expect you to be able to get these really, really easy. I don't expect you to be able to figure these out really quickly and easily. These are hard. And not only are they hard, but they are difficult to come up with figuring out the plan. Like to be able to change this here to exponential. How did I know to do that? Well, it comes with practice. So I'm expecting you to work hard on these and to try doing what you can, but I don't expect it to come real easy, and I have no problem with you getting a hold of me about getting help on these. Alright, so that's it for lesson 11.4. I'm sorry, 11.3.